understanding everything?
Yes, ma'am. I was asking.
If you have any doubt, you can ask. Okay. Now, from December onwards, after you finish off your examinations, we can meet someday in college, not in groups. One or two of you can come. If you have any doubt, we'll sort it out because almost your syllabus is going to be over, so we can clear the doubts now. All right. If you have any doubt, make an appointment, both of us, or two of you, one of me, one me, so three people. We can meet in the college and clear all your doubts. Okay. Those who had missed previous classes or those who are attending all the classes, these people are attending all the classes whom I can see on my screen right now. You have 100% attendance. So I am always there for you. If you have any doubt, please call me. We will fix an appointment and go to college and meet. Okay. All right. So let us start today's topic. Today's topic is unbalanced assignment problem. What is the meaning of unbalanced assignment problem? It means that the number of rows and the number of columns will not be equal. And that is how you cannot determine the order of the matrix. So then what you need to do, if you receive an unbalanced assignment problem, we have seen what to do with an unbalanced transportation problem. Now we will see what should be done for an unbalanced assignment problem. Okay. So in the question, we quickly write down the matrix in your copy. The words and lines, you can write it later on. Jot down the matrix in your copy first. There are 4 jobs to be assigned to 5 machines. Only one job can be assigned to one machine. The amount of time in hours required for the job per machine are given in the following matrix. So these are the amount of time in hours. Okay. Find an optimum assignment of jobs to the machines to minimize the total processing time, and also find out for which machine no job is assigned. What is the total processing time to complete all the jobs? Don't get scared by seeing it as a time given to you. Even if it is time, your objective should be to minimize the time in order to process the job. So cost also minimization, time also minimization. So same process. Okay. But there is a major difference in this sum. The number of rows are less than the number of columns. So quickly jot down the matrix first, then I will move ahead. The matrix says machines at the top, 5 machines, A, B, C, D, and E, and 4 jobs are there, 1, 2, 3, and 4. So this is not a square matrix, right? In the first row, the numbers are 4, 3, 6, 2, 7. Second row 10, 12, 11, 14, 16. Third row 4, 3, 2, 1, 5. And the fourth row is 8, 7, 6, 9, 6. These are all hours. Okay, these are all amount of time mentioned in hours. Okay, and I hope you have finished of writing. See, you are asked obviously to find out the total processing time and the minimum total processing time rather, and also you have to find out that which machine is going to remain vacant, to which machine no job is going to be assigned. See, there are 4 jobs but 5 machines. So obviously one machine will have to remain idle, isn't it? And the rule is 1 job, 1 machine, 1 person, 1 activity, like that. So you cannot assign 2 machines to a single job. That is why it is an indicated fact in this problem that one machine has to be kept idle. No job can be assigned to one machine. Now, which is that machine to which the job cannot be assigned. That also we will have to find it out. That is not a problem. When you will assign in the final step, automatically that will come out. Okay. So let us see what to do. Since you will write in the solution, please. Since the matrix, since the cost matrix, you can also write time matrix. Since the time matrix is not a square matrix, comma, the problem is unbalanced. The problem is unbalanced. So we add a dummy. So we add a dummy job. So we add a dummy job. Five with corresponding entries 0. Okay, see, the jobs are less in number, right? So we need to add a dummy job and name it as 5. But we cannot put any numbers in this row. We have to assign all zeros here. All the entries will be 0. Okay, just like transportation problem. So, modified matrix, write this one. Right, modified matrix, the same number, same matrix you copy, but add one dummy row and name it as job 5. All the numbers corresponding to this row will be 0. That means no time assigned, because this is a dummy job. This we are doing for making our Hungarian method applicable. Otherwise, we won't be able to apply Hungarian method of assignment problem solution. So we are adding a dummy row having all the time limits as 0. Write down the matrix. Write down the modified matrix by putting a dummy row as 0. Now it has become a square matrix. Now no longer it is a unbalanced assignment problem. This has become a square matrix, so a balanced assignment problem. Done? Done till this much?
Yes, ma'am.
Okay. Now let us proceed as per the steps of Hungarian method. Now we will identify the minimum element from all the rows, and then we will deduct that minimum element from all the other elements in the respective rows. So then you write we subtract the smallest element from all the elements in the respective rows. Right, do the second matrix on your screen. The minimum element in the first row is 2. So we will deduct 2 from all the other elements in the first row. So it will be 4 minus 2, that is 2, 3 minus 2, 1, 6 minus 2, 4, 2 minus 2, 0, 7 minus 2, 5. Then come to the second row. In the second row, the minimum element is 10. So 10 minus 10, 0. 12 minus 10, 2. 11 minus 10, 1. 14 minus 10, 4. And 16 minus 10, that is 6. Similarly, we'll do for the third row. In the third row, the minimum element is 1. So 4 minus 1, that is 3. 3 minus 1, that is 2. 2, 2 minus 1, that is 1. 1 minus 1, that is 0. And 5 minus 1, that is 4. For the fourth row also, we'll do the same thing. In the fourth row, the minimum element is 6. So it will be 2, 1, 0, 3, 0. And the fifth dummy row will remain same because no, you cannot do anything with that because all the numbers are 0. So you will again write 0 in the in the fifth row. Okay. So now, since each column has minimum element as 0. Now the next step was to do the same thing for all the columns. But if we get at least 1 0 in all the columns, then there is no point in doing the next step. So we will first check whether all the columns are having at least 1 0 or not. Yes, all the columns are having at least 1 0. So there is no point in doing the next step. So now directly we will draw the minimum number of horizontal and vertical lines. Do it please. Same thing you will have to do. Just like the previous questions, you have to do the same thing. Please move ahead. I'm giving you attendance, okay? Please go on doing, don't stop. You still have 9 minutes in hand to join the next class. So please do as much as possible. Finish off in the class timing itself. So, done? Have we drawn the lines?
Yes, ma'am.
Okay. So it will be 4 in number, right?
Yes, ma'am.
First set of lines will be 4 in number. So they are going to be less than the order of matrix, because now the modified order of matrix is 5. So we need at least 5 lines. So what we'll have to do? Same process. We'll now form the second modified matrix by subtracting the smallest uncovered element from the remaining uncovered elements and adding it to the element at the point of intersection of the horizontal and the vertical lines. So that number of rows has not been, sorry, number of lines has not been drawn and shown in the problem, but you will show, okay? Do not skip any step. When you are practicing the sum, do not skip any step. If you do it in the exam, you are going to have a deducted mark. So do not skip any step. You do the same, you do the things, okay? Uncover minimum uncovered element is going to be 1. So you make a new matrix which will have the element 2, 0, 3, 0, 4, then 0, 1, 0, 4, 5, then 3, then 1, 0, 0, 3. Next it will be, this is a point of intersection in the fourth row, first element. This is a point of intersection. It will be 2 plus 1, 2 plus 1, so 3. Then it will be 1, 0, again a point of intersection. So it will be 3 plus 1, 4 and 0. Last one has 2 point of intersections. So first element will become 1, then 0, 0. Then again the fourth element in the fifth row, it will become 1 and 0 will remain 0. Quickly form the second modified matrix and then draw the lines again. Then draw the lines again. I think this time you will have 5 lines drawn to cover all the zeros. Once you get it, then you can assign. So how will you assign? Again the same technique. You'll have to find, it is having perfectly 1, 0 in it. Are we having that row? We don't have. You have to check the columns. Yeah, in the first column there is a perfect 1, 0. Right? We can check the column wise also, okay? If there is no perfect single 0 in the row side, you will go to the columns. In fact, in this problem, you have to check the columns only because machines are at the top. Right? So once you check the rows, no single row having perfectly 1, 0, directly you will go to this column side. Okay? So in the columns, first column is having a perfect 1, 0. So this, has anyone typed anything? Please unmute and tell me. I am unable to see the chats. Okay, so in the first column, this second row, in the second row, the second element in the first column is the perfect single 0. So you will mark it, you will circle it or put a square and you will cross all the other zeros in that row. You'll need some time as you'll have to draw a fresh matrix and then only you can go for the assignment. Give it a try. If any problem, we'll discuss it later on, okay? On Monday, we'll discuss. So you give it a try and do let me know if you are facing any problem. You will draw fresh matrix and then you will make the assignment, okay? Once you make the number of rows, number of lines, once you draw and make it 5, again you will draw fresh matrix and in that you will assign, okay? Do it. If any difficulty, we'll discuss later on. It's already 7:40. Okay, then done for today. Attendance was given. So